We've learned a lot about waves so far. We know about wave speed, we know about amplitude, we know about frequency, we know about all of those things. Today what we're going to look at is we're going to look at what happens when waves hit each other. Today we're going to be investigating some slinky springs and some pulses that we can make on these slinkies. Now to make a pulse, all you do is you go back and forth very quickly with your hand. Now to do that, I'm really good at this. I've been doing this for years. You go straight out and straight back and you make a really nice pulse. There's a pretty good chance some of you guys are going to suck at this. I'll see a lot of this, which is not a good pulse. A good pulse is a quick flick of the wrist. Is really all it takes. So the first thing you're going to investigate is if I send a pulse down on this slinky, down that way, how is it going to return back? And there's two ways we're going to do that. We're going to send a pulse down with what's called a fixed end. And a fixed end is when your partner is just holding the other side so it can't move. And it's going to look something like this. Now, we're going to be investigating how that works. How did the pulse that I sent down compare to the pulse that came back? And those are the things you're going to kind of look at first. Then you're going to use what's called a movable end, where your partner is going to actually tie a string to their side so that the end of the slinky can actually move back and forth. We're going to do some investigating on that then. Finally, we're going to look at what happens when two waves meet. Now to do this, you and your partner both have to make pulses. So you both got to practice and make sure you're good at it. So if I make a pulse on this side, my partner makes a pulse on the same side, what happens when they meet? Or what happens if I make one on this side, my partner makes one on the other side? What happens when they meet? So you're going to do a lot of investigating with these slinkies today in terms of just making pulses and seeing how these displacements of the slinky interact when they actually get superimposed on each other. Superimposed means to be placed on top of each other. So good luck, have fun, and I'll be around to answer any questions. So what do we find out? We found out that when waves are on the same side of each other, we call that in phase. And when two waves in phase meet, they actually do what's called constructive interference. Constructive meaning to build up. Now, I want to actually show you how this works with some drawings. And you're going to make a lot of these drawings today. And it kind of works like this. If you have two waves that are moving towards each other like this, this would be two waves that are in phase. When they hit, they actually double their amplitude. The amplitude gets really big. And you probably saw this in the slinky. After they hit, you most likely figured out that they actually pass through one another. That's really important because if sound waves actually bounced off of each other, we'd never be able to hear each other talk. If one person was talking and the other person was talking, those waves would bounce off of each other and you'd never be able to hear that other person. It's pretty fortunate that these waves can travel through each other and we can talk and listen to each other even as other sounds are being made. This is called constructive interference. Now this works with other types of waves. Now in a slinky you can really only make these like rounded waves. But with other things like electricity or those kinds of things, we can make waves that are different forms. We can make waves that are squares. Essentially what that means is you turn the electricity on, you shut the electricity off. So this might be a voltage. And you may have a voltage that's constant right here. You turn it on, you turn it off. What happens when another voltage over here is going to meet? Well, in this case, this voltage here, which is wider, is going to be there. And then this voltage here, which is smaller but taller, is going to be there as well. So right when they meet, you're going to get a situation that looks like this. After they meet, you're going to get the long one there and the taller one there as they pass through one another. So these kinds of interference patterns, the superposition patterns, we can use for any type of wave that we look at. This is constructive interference. Destructive interference is pretty much the same thing, except when they hit, you have a positive and a negative. This would be on the other side, a negative, and when those amplitudes interact, they don't add. Well, they do add, but one of them is negative, so they end up subtracting. So all of this can be done with superpositions of waves. This is going to become really important tomorrow when we start to talk about resonance.